Namaskar, good morning and welcome to this session 2 on understanding hazards under section 2. Objective of the session is number 1 to explore the various type of hazards, to examine their key characteristics. Number 3 to understand their wide ranging impacts on the people, property and environment. By the end of the session, the participant will have a deeper understanding of hazards and their role in disaster preparedness and mitigation. Why it is important to understand hazards? A clear understanding of hazard is essential for effective disaster risk management. Without understanding sources, nature and impacts of hazards, planning and response efforts cannot be effective. Let us go to hazards and their classifications. A hazard is any phenomenon with the potential to cause disruption or damage to the lives, livelihoods, infrastructure or the environment. There are many types of hazards. Some hazards are natural events. Natural hazards can be earthquakes, floods and hurricanes originating from natural processes, often causing wide range damages. For example, 2004 Indian Ocean tsunami devastated multiple nations with significant loss of life and huge devastation. Human made hazards, they result from human activities including industrial accidents and deforestations. For example, we can consider Bhopal gas tragedy of 1984, which caused thousands of fatalities due to a gas leak in Bhopal. There is a category which is called the complex hazards. It is a mix of natural and human made factors such as pandemics and climate change. Under this category, the example is COVID-19 pandemic revealed global vulnerabilities across health and economic systems. What are the importance of recognizing hazards? It enables effective preparedness through early warning system and planning. It supports targeted mitigation strategies to minimize impacts. It builds resilience and ensuring communities can recover and adapt to the future. Now let us move to the characteristics of hazards. The first characteristic is the frequency. It refers to how often a particular hazard occurs within a specific period, such as annual monsoons or rare events like tsunamis. For example, seasonal floods in India occur frequently, while volcanic eruptions are relatively rare. Second characteristic is intensity. It indicates the severity or the magnitude of hazard. It determines the level of damage it can cause. For example, high magnitude earthquake in Bhuj in 2001, which had the catastrophic impact. The third characteristic is duration. It describes how long a hazard event persists, ranging from minutes like earthquakes to months like droughts. For example, prolonged droughts in sub-Saharan region can span years, impacting livelihoods and ecosystem. And the fourth characteristic is spatial extent. It refers to the size or geographic area impacted by the hazard, from localized events like urban floods to global phenomenon like climate change. It can be referred by an example like 2010 Icelandic volcanic eruption disrupting air travel across Europe, showcasing wide spatial impact. Now let us come to the discussion of hazard spectrum. Hazard spectrum represents the broad continuum of hazards ranging from sudden onset events to slow onset crisis, each requiring distinct preparedness and response strategies. Under sudden onset hazards, it occurs rapidly, with minimal warning time. These hazards can immediately impact. Examples are tsunamis or industrial explosions. And slow onset hazards. This develops gradually, offering time for mitigation but often overlooked until critical. Examples are droughts and climate change. What is the takeaway from the discussion so far? Understanding natural, human-made and complex hazards with examples like the Indian Ocean tsunami and Bhopal gas tragedy all required a tailored disaster preparedness response. Number 2, identifying frequency, intensity, duration and spatial extent helps assess risks and plan intervention measures. Number 3, recognizing the hazard spectrum from sudden events like tsunamis to slow crises like climate change ensures timely and adaptive measures. Now let us move to hazard vulnerability. What is the vulnerability? Vulnerability is the extent to which individuals, communities or systems are exposed and susceptible to hazard impacts. This is shaped by their ability to adapt or to understand risks. There are certain determinants of vulnerability. Number 1, economic conditions. Limited resources hinder protective measures and recovery efforts. Number 2, governance. Strong systems enable effective risk reduction and disaster response. Weak governance system amplifies risk. Number 3, infrastructural quality. Resilient infrastructure mitigates impacts while outdated systems exacerbate damage. Social systems. Inequalities and limited access to resources increase risk for marginalized class of people. Now the impact. High vulnerability amplifies hazard consequences leading to greater loss of life, damage and prolonged recovery, especially in resource limited settings. Addressing vulnerability is critical for building resilience and reducing disaster risk. Now let us discuss some of the global examples of hazards. Hurricane Katrina, you might be knowing, occurred in 2005 in USA. Its category 5 hurricane caused severe flooding in New Orleans due to levee failure, resulting in 1,500 deaths and $12.5 billion damage. And about the Indian example, in 2004, the Indian Ocean tsunami, earthquake triggered tsunami, killed around 2,30,000 people across 14 countries, devastating coastal communities and highlighting the need for early warning system. Amazon wildfires. Fires fueled by deforestation and droughts destroyed vast rainforest areas, causing biodiversity loss and contributing significantly to climate change. Indian examples of hazards. Uttarakhand flash flood in 2013. Its devastating cloudburst led to flash floods, particularly in Kedarnath region, causing 5,700 deaths and destroying huge numbers of homes, roads and bridges. The disaster highlighted the vulnerability of the hill region in extreme weather conditions and its need for sustainable developmental practices in sensitive regions of the hills. Bhuj 2001 Gujarat earthquake occurred at 7.7 magnitude scale. It killed around 20,000 people, destroyed 1,50,000 structures. This tragedy emphasized the need for earthquake resistant infrastructure and robust disaster preparedness measures to ensure safety in such incidents. And again, a Chennai floods in 2015, if you go through that, you will find that record breaking rainfall worsened by poor urban planning caused severe flooding in Chennai. It led to over 500 deaths and economic losses exceeding around 20,000 crores. The disaster highlighted the importance of efficient drainage system and sustainable urban planning. Now let us move to hazard identification techniques. There are many hazard identification techniques. One is the historical data analysis. Under historical data analysis, we study the past disaster records to identify the patterns and we predict the future events, asking for long term preparedness measures. The second identification technique is risk mapping. We are using GIS tools to map hazard prone areas like floodplains, guiding mitigational and resource planning. The third tool is community participation. It involves locals to share insights on hazards and vulnerabilities, enhancing community relevant risk identification measures. Now let us move to hazard mapping. Hazard mapping is a visual representation. It identifies areas vulnerable for hazards like earthquakes, floods and landslides. It is essential for disaster preparedness, guiding land use planning, research mitigation and emergency response efforts. Let us go for some examples. Examples are earthquake zones. Japan's seismic maps inform building codes and retrofittings. Flood maps, Brahmaputra basin flood maps aid forecasting and relocation planning. Now let us discuss what is the role of climate change on hazards. Number one role is worsening weather events. Climate change exacerbates the intensity and frequency of hazards like rainfall or no rainfall, cyclones and heat waves. Long term impacts, rising sea levels and melting glaciers increase flood and drought risk. Global response, it emphasizes on mitigation and adaptation strategies in international agreements like Paris agreements and so on. Now let us discuss human induced hazards. We have already discussed about Bhopal gas tragedy of 1984, which was one of the world's worst human induced industrial disasters and having great impact on the lives and property and long term impact. Again, under terrorism, it is also a human induced disasters. 9/11 attacks in the USA destroyed 2 twin towers, led to thousands of deaths and transformed the global security policies. Under category of pollution, Delhi's air quality crisis, it is one of the human induced air pollution crisis where smog from vehicle emissions, industrial output and crop burning poses serious health risks and disrupt daily life. And the third category is the complex hazards. These hazards involve a combination of natural and human induced factors. Examples are COVID-19 pandemic, a global health crisis with economic and social impacts. The impacts of such hazards are manifold. Disasters result in casualties, often affecting vulnerable population disproportionately. Damage to infrastructure, loss of livelihood and reduced economic productivity. And the third part is degradation of the ecosystem and biodiversity. Let us try to learn and understand what are the mitigation for containing hazards. Under hazard mitigations, there are two types of measures. One is the structural measures, another is the non-structural measures. Under structural measures, earth resistant design. The buildings engineered to produce seismic forces utilizing features such as flexible materials and shock absorbers to minimize damage. Let us discuss the Japan's example. They are having the advanced construction techniques that include base isolation system that separate buildings from ground movement during earthquakes and thus reduces structural damage and protect lives. Flood resistant construction. Structures designed across the river like dams and along the rivers like levees, they are there to mitigate the flood impacts by elevating foundations and implementing water resistant materials. Flood barriers and levees are built to redirect or contain water during heavy rainfall or storm surges. Let us discuss with an example. Elevated homes in flood prone areas like Kerala and Netherlands, levee system effectively safeguard communities from recurrent floods. Retrofitting existing structures. Strengthening older buildings by incorporating modern safety techniques such as bracing, anchoring or dampers to improve their ability to withstand hazards. Retrofitting efforts in California have upgraded bridges and public buildings to meet seismic safety standards, significantly reducing risk during earthquakes. Now let us discuss hazard mitigation. There is another category is community based hazard mitigation. This is a non-structural measures. Here number 1, local knowledge integration. By integrating local knowledge, we utilize the community's lived experiences and traditional knowledge to identify hazards and design context specific solution measures accordingly. Number 2, community preparedness program. It conducts regular awareness programs, evacuation drills and first aid training to ensure readiness during emergency. Number 3, participatory risk assessment. It involves community members in mapping hazards, assessing vulnerabilities and prioritizing mitigation measures. Response mobilization empowers communities in pooling resources, establish emergency funds and organize local response teams for swift action. Number 5, sustainable practices promotion. It encourages practices like afforestation, sustainable land use and waste management to reduce environmental vulnerability. And number 6, collaborative governance strengthens partnership between the local authorities, NGOs and residents to implement disaster risk reduction strategy effectively. And out of that, number 7 will be the building resilience. This will be the last but most important, and it focuses on long term capacity building, improving infrastructure and enhancing livelihood to reduce hazard impacts and helping for the early recovery. Now let us move on to another non-structural measures, that is the early warning system. Early warning system is a real time monitoring system. It utilizes technologies like satellites, weather radars and seismic sensors to detect, track hazards in real time. Timely alerts disseminates warnings through multiple channels including sirens, SMS alerts, apps and community radio to ensure rapid communication. And number 3 is community awareness and preparedness. Combines early warning with public education campaigns to inform communities about hazard risk and evacuation protocols. And the fourth one is multiple hazard coverage. It develops integrated system capable of addressing various hazards such as flood, cyclone, tsunami and earthquake. Now there is one segment, urban planning, and by sustainable urban planning hazards can be mitigated, and there we make intervention of both structural and non-structural measures. Number 1 is zoning regulations. Establish rules to restrict development in high-risk areas such as floodplains, coastal zones, reducing potential exposure to hazards. Number 2 is green infrastructure. It incorporates in urban planning natural solutions like urban parks, green roofs, rain gardens to absorb rainwater, reduce runoff and manage urban flood effectively. Let us discuss with an example. Singapore's sustainable urban planning integrates green infrastructure to minimize flooding while effectively urban livability and developing resilience. Now let us move on to technological intervention. Technological innovations help in reducing the risk. Number 1 is GIS and remote sensing. Tools like GIS and remote sensing provide critical data to identify hazard prone areas and assess vulnerabilities, enabling targeted disaster planning and resource allocation. Example is GIS was instrumental during 2015 Nepal earthquake for mapping affected regions. Second category is artificial intelligence and big data. This enhances disaster forecasting and risk assessment by analyzing the patterns and generating predictive insights for hazards in the future, hazards like the cyclones and earthquakes. Japan uses artificial intelligence in tsunami and earthquakes early warning system for faster alerts. Use of drones. It is also used for rapid post disaster assessment, capturing detailed visuals to guide rescue and recovery operations. Drones were deployed for Hurricane Maria. Drones assessed damage to prioritize relief efforts. And at the end of the session, we can conclude that economic, governance and infrastructure vulnerabilities amplify disaster impacts as seen in Hurricane Katrina and Gujarat earthquake. Second, we have learned climate change worsens natural hazards, while human actions like pollution and industrial accidents such as Bhopal gas tragedy increases the risks. Technologies like GIS mapping and AI combined with green infrastructure enhance planning and reduce the risks. Examples include Japan's seismic retrofitting and Singapore's urban designs. Number 4 is urban planning system and participatory planning empower community and this enhance the resilience. This helps and it exemplified by India's cyclone warning. With all this, it is the end of the session. Thank you very much. We will see you again in the next session. Thank you.